Hello YouTube, welcome back. In today's video we're going to resume talking about malware analysis. If you remember, in a previous video we talked about static malware analysis. In today's video we're going to go over a brief on dynamic malware analysis. So to start with, we're going to work on 4 items: definition, considerations, purpose, and tools of dynamic malware analysis. Okay, so to start with, what is dynamic malware analysis? Let's provide some definition before we start working on other stuff. So the definition here, it can be defined: dynamic malware analysis is characterized by opening the file or opening the binary in a sandbox environment, or in, let me say, a dedicated environment. So say you have a sample such as payload. Let's say it's an executable sample. So in order to dynamically analyze this sample, you would go ahead and open it. So before doing any sort of analysis using dynamic malware analysis tools, we first open the file. Now, the most important thing is when we open the file, we don't open the file in a live environment. We're going to talk about this in the considerations. But for now, dynamic analysis can be defined as opening the file, opening the binary in a controlled environment. In static analysis, we actually saw that the main highlights in that kind of analysis, which is a static analysis, is that we do not open the file. We do not open the binary. Here we open it in order to observe its behavior. So when opening the binary, we give it the go-ahead to do what it was intended to do, right? So based on that premise, we will be able to monitor and extract all of the artifacts related to its behavior. So that can be called the definition of dynamic malware analysis. Okay, so now we open the binary. So what do you mean by a controlled environment? So a controlled environment can be any operating system you dedicate for malware analysis. For example, you can build your own VM. Okay, in this VM, it can be Windows VM, it can be Windows VM, and it can be Linux VM. Now you can build your own dedicated environment, all right, and install all of the required tools. But there are other tools you can use online, unless you want to develop a machine for the long-term use, or if you want to develop your own machine and release it to the community. That's a different story. But that is what we mean when we say a controlled environment. Okay, now let's talk about the considerations before embarking on analyzing malware samples using dynamic analysis. So the first consideration we would talk about is, as I said earlier, it's the controlled environment. So we create or use a controlled environment dedicated for malware analysis. Okay. The reason behind using a controlled environment is that if you open the sample using a live environment, such as the machine you're using, your own machine, the endpoints you're using in your corporate, the malware will not do good, right? It will damage the network, it will steal the files, it will do what it was intended to do. So that's why we open the file in a sandbox environment. So a controlled environment can be called sandbox. So that is the sandbox, a controlled environment. Okay, now that's the first consideration. The next consideration after we create a controlled environment is that we take a snapshot of this environment. Okay, so we take snapshot. Of course, the snapshot is taken before you analyze the file. So before, I'm gonna type before, like that, before analyzing or opening the sample. So why is that? The reason is that some samples are classified under ransomware. So ransomware is a family of malicious software that is designed to encrypt the whole files, and encrypt your files, or even the whole operating system, and demand a ransom in order to decrypt your files or restore back your operating system. That is why you take a snapshot. So in case you encountered a ransomware in your analysis, so basically you will be able to restore back to a clean slate, or to state 0, I'm gonna call it. So basically you can restore back to state 0 where you first installed or created your virtual machine. These are the most important considerations when dynamically analyzing malware. Okay, I feel the need to write this separately or individually is that don't, okay, open the sample on a live machine. A live machine is the machine that you are using for your work, for your own purpose, for gaming, production, whatsoever. Don't open it on a live machine, no matter the damage associated with the binary. The malware can be less damaging, so it doesn't need to be a malware. It doesn't need to be any sort of Trojan or ransomware. It can be just a small virus that would make your computer slow. But who wants this? If you want to analyze it, just do it in a controlled environment. If you don't want to analyze it, we're going to talk about online tools which you can use to determine an idea, or determine what would the malware do. Okay, so what's the purpose of dynamic malware analysis? Now we talk about the purpose. So why aren't we good with only static analysis? The reason is that some malware authors or developers use something called let me remove this one. Use something called packing. Okay, so we have the idea of packing, or we call it sometimes the obfuscation. So this technique is used by malware developers to obfuscate and encrypt the contents of the malware. Okay, so if the contents of the malware is encrypted, you can no longer benefit from static analysis, since most of the strings or the output of the static analysis tools will be giving you obfuscated content. So if you run strings, for example, if you run strings on an obfuscated payload, say obfuscated.exe, okay, so the output of strings will be something that you can't understand, encrypted. So you won't be able to see the imports, the functions, the API calls, IOCs. That's why one of the reasons, of course, we resort to dynamic analysis. We want to see what the malware does in real time. That's one reason why we resort to dynamic malware analysis. Now, other reasons can be related to disclosing the full behavior of the malware. So in a static analysis, yeah, I know we can see the hash, I know we can research online, I know we can extract the API calls, understand what kind of DLLs are called by the malware, but this doesn't reveal the actual behavior of the malware. It only gives you 20%, 30% of what the malware does. Now, sometimes we can be good with only static, of course, with the aid of online tools or with the aid of security solutions. But if you want to completely analyze the malware, you would resort to dynamic analysis. So you would combine the results of static and dynamic. Unless you are reverse engineering the malware, that's different story. Okay, so beside the reasons I just outlined, the purpose of dynamic analyzing malware, first to extract the network connections. So we want to see what are the calls the malware makes when it is launched. The calls can be to domain names, to IP addresses, to host, whatever. So we want to see what are these calls. So when we are able to see these calls, when we are able to see the domains the malware is trying to connect to, we can draw a picture of what kind of sample we are dealing with. The next thing we want to see is the processes. So what are the processes launched by the malware when it is opened on our environment, right? The third purpose is that we want to reveal actually the registry keys that are modified by this sample. And this one is actually related to Windows. So this is only for Windows. In Windows, the registry component or the registry actually is a big part of Windows. So modifying a registry would impact the environment, would impact how Windows works. That's why we want to see what are the registry keys queried, modified, or created by the malware or the sample. It may not be a malware, right? So network connections, processes, registry, keys, and of course we want to see lastly the startups. Oftentimes malware samples would create entries in the startups so that when the computer boots up or when you first start your computer, the malware will inline start with your PC and start to work. So basically we want to see what are the startup entries created by the malware. Okay, so now we know the definition, considerations, and purpose of dynamic malware analysis. Let's now talk about some of the tools used for dynamic malware analysis. Okay, so tools of dynamic malware analysis. What are some of the tools? Now, as we said earlier, guys, the first thing is that we need a sandbox. So sandbox can be of your own creation, your own VM, or can be an online service. What are some of the online sandboxes? Some of the online sandboxes are Kuko Sandbox. So Kuko, here it is C, not K. Let me correct this one. Kuko Sandbox. Now Kuko Sandbox can be installed locally as a VM, or it is provided as an online service as well. You don't need to install anything. Now the next thing, or the next online sandbox that you can use is actually called the Cape Sandbox. Again, Cape Sandbox can be installed locally, okay, or online. These are very supported sandboxes, and it has huge community support. Now, other online tools can be, for example, we have, as you know, Autorun. So Autorun is an online tool that you can use to analyze your sample. You can submit the hash or upload the sample, and Autorun will do the analysis. Also, we have hybrid analysis. Hybrid analysis is a service through which you can submit a hash or a file, uploading a file to be able to reveal its, it will give you a report. In this report or throughout this report, you can take a look at the behavior of the malware. These are online and offline sandboxes. Now let's talk about some of the tools that you can use on your own, okay, in your own machine if you want to analyze it locally. So say you don't want to use any of these services, you want to build your own your offline sandbox. So what are some of the tools that you would need to install? So let's talk about some of the tools, and let me draw a row here like that. If you want to use your own VM, what are some of the tools? So the first thing is that we have Process Monitor. As the name suggests, this tool will aid you in displaying all of the processes, the registry keys, and the network connections used by the sample you are analyzing. Also, we have process hacker. Now, process hacker can be called as an advanced version of the task manager. It will display all of the active processes, the related API calls, memory sections. You can fully analyze a process using process hacker. So that's one. Also, we have Autoruns. Autorun is a very popular tool. It also displays the processes, the startups, entries created by the sample, and the memory sections as well. Recommended tool. So process monitor, hacker, Autoruns, and of course don't forget process. It was something like that. This one can be considered as a static analysis tool, but also it provides the ability to use graphs that will depict the malware behavior. Again, we have Wireshark. Although Wireshark is used for analyzing networks or as a network analyzer, you can use Wireshark. Once you open the file or the sample, you can open Wireshark after that to be able to see the network connections that are made by the sample. So Wireshark is a great tool if you want to analyze the network activity of the malware. Also, you have TCP dump. Okay, now these are the dynamic analysis tools. Now let's move to some sort of practical scenario. We will take a look at a report curated by Hybrid Analysis. So there is a sample submitted to Hybrid Analysis. We're going to talk about the sample, and we will walk you through the report curated by this online sandbox. So let's say you have this hash. We're going to click on search, and when you click on search, Hybrid Analysis will run a quick search on its database. If people have submitted a sample, this sample before, it will give you the number of times and the list of reports that are created when people before you have submitted the sample. So as you can see, they are ordered, descending using the date. So let's take a look at this one. This one is actually a red line. The file name is redline. Let's take a look at that. Now, when we first open the report has many sections, as you can see. It's very important to understand what you want out of this report, not to be overwhelmed by the wealth of information you see here. So the first thing, we have the risk assessment section. Here we see information related to the damage of the malware, the impact of the damage or the scope of the damage, the classification of the file. So basically, as you can see here under network behavior, we see that the malware contacts 8 domains and 8 hosts. Fingerprints, persistence. These sections are actually categorized as risk assessment sections. Here we can see the map to MITRE, ATT, and CK. So if you remember, MITRE, ATT, and CK is a framework that you can use to research adversary techniques. So basically, if you want to match the behavior of the malware to those outlined in the MITRE, ATT, and CK, you can use this section. Let's take a look at this. View all details. And here we can see all of the techniques used by the malware. As you can see, execution, it uses privilege escalation. It also evade defensive techniques. If you go down, it also has perform credential access, discovery. So along with every adversary technique, you would see those that match the malware behavior. Okay. Now we scroll down, we see these are the malicious indicators. Now using these indicators, the sandbox deduced that the sample is malware. Here it would give you the reasons why this sample is considered as malware. For example, as you can see here, let's see this one. Installation persistence. Allocates virtual memory in a remote process, writes data to a remote process. These are some of the indicators that the sample is malware. Okay, if you scroll down, we see here the details of the file, like the hash, the architecture it was designed to run on, and the size of the file. These are details that you can get out of static analysis. The sections of the file, again, we talked about these in the static analysis video. The imports, you can get them also from static analysis. Here are screenshots provided by the sandbox itself of outlining what happens when they open the file. As you can see, this is the CMD that has been spawned upon opening the file. And then as you can see, the file seems like a normal installer. Install some software. And that's it. As you can see, when the service tried to install the software, it encountered an error. So a normal person would think that this program doesn't work or isn't working. But in reality, what happened is that once the person proceeded with opening the file and installing the service, it actually installed the malware on their network without their knowledge. These are the processes created by the sample. You can get these if you are analyzing your malware locally. You can see these using Process Hacker or Process Monitor. Network analysis. These are the domains and hosts contacted by the malware. One hallmark of malwares is that they contact or they create outgoing calls to domains and hosts or IP addresses. Here is the HTTP traffic witnessed on the malware. So basically, sometimes malwares would communicate with their CNC server, right, using HTTP, maybe to post data that has been exfiltrated from the victim. So when the malware steals or spots data that it wants to steal, it can upload these data using HTTP to an offshore server. So the Kata alerts, these are the signatures that are related to IDS. The strings, extracted strings, again, you would get these if you are analyzing the malware static, but again, if it was backed, you would need to do dynamic analysis, as I told you earlier. Extracted files, these are the files created by the sample, and these are, as you can see, the details about every file. And one good thing about this sandbox is that it gives you the AV scan result. So it performs some sort of antivirus scan, or it submits maybe the files that the malware creates to an online malware scanning service to be able to give you a label on every file that the malware created. These are the DLLs, and as you can see, they are clean. And here you will see community support. If people have comments about this malware, you would see what they have to say here in the community support or the community comments. So that is one rundown on using one sandbox online. Now, what I did in order to summarize everything we talked about in the static and dynamic malware analysis, I have created one node file under the nodes library. It is called malware analysis. I have listed the static analysis and dynamic analysis, both definition and tools, and also talked about reverse engineering. If you are into reverse engineering, I've listed the use of some reverse engineering tools such as Radar 2, PDF analysis, Microsoft analysis. Of course, this is not everything about reverse engineering on malware analysis. I'm constantly updating the notes. You can also subscribe to the channel membership if you want to subscribe to the notes. So that was for today's video, guys. I hope you like that, and I will see you in the next one.